Now let's see with y. When you do with respect to y, you can say this is a pure constant, is that right? With respect to y. But nothing wrong if you just say that, okay, I forgot to identify that, but still I'm trying like this. When you're taking derivative with respect to y, isn't it 0 here? If you go with the product rule, it's still no problem, because you will have the balance. This one will give me e to the 2xy times 2x, because I'm doing with respect to y now. So this goes to 0, and then you have that one, which is 12 x squared, where 6x times 2x, 12x squared, e to the 2x y. That's all. You got it? So this is partial derivative, but you might need sometimes product rule. With respect to x, we have seen first function is a variable x, and the second function has also variable x, so I must use product rule. But when I use derivative with respect to y, if I don't use product rule, it's still fine, because 6x is a constant. I will leave it there and then take the derivative of the second part. Alright? So do the homework, you will build your understanding, and we have our videos too. So now I'm going to the next part. Next part, because in the next section we will have some application problem. So that's why we give you some training of making derivatives, and then optimization problem is coming later. So application of derivative will be there. All right. So I'm taking, next one is like this, so that you have a function fxy equals, say, 4x squared y squared. For example, you want to find fx. What is my fx? We know that it is 8x y squared. Is that true? I want to take derivative again with respect to x. So take derivative from here. It will be 8 y squared. Do you see that? Understood? Okay. So this is called second order derivative. Now I'm going to take fy. So fy will be, I will keep 4x squared. Y squared will give me 2y. So that means I have 8x squared y. Now take again fyy. So that will give me 8x squared. Now next question is, if I want to find fxy, what happens? So you see that here fx, and then you take derivative with respect to y. So is it 8x times 2y? So that gives me 16xy. Now I want to do another way. Fy I have already here. I want to take derivative with respect to x. So with respect to x here, it gives me 16x, and then I have y already. So are they same? Yeah, they're same. So then remember that when you have derivative with respect to x then y, will be same as first with y then x. They are same. Okay? If you just understand this, then the next section you will understand. Alright, so I'm done actually with this partial derivative concept. Now let's visit homework questions. So I am doing now this problem. Okay. So just look at here, you have fx, y, z is a 3 variable function. fx, y, z is 8 over x squared plus y squared plus z squared, okay? Like that. So if I write this function as this, see here, 8 and then x squared plus y squared plus z squared to the negative 1. Is it okay? Yeah, let me pull this way a little bit. I'm sorry. So I need some space here actually. Okay. So I'm writing like this, equals 8 x squared plus y squared plus z squared to the negative 1. Is that okay? Because you have a function in the denominator, so you can write this one as negative exponent. So then what happens, del f del x, 8, and then you have a negative 1, then you have x squared plus y squared plus z squared to the negative 2 times what? Multiplied by the derivative of inside. So derivative of inside with respect to x will be 2x. We are done? Yeah? So when you are doing derivative with respect to y, for example, you are writing del f del y, or you can say fy here. So it will be same thing, like 8 negative 1 x squared y squared z squared to the negative 2 times 2y now. Yeah? And then the next one will be times 2z, like that. Isn't it? Right. And then you can pull back when you have a negative 2 exponent, you can put it back in the denominator with a positive exponent. Make sense? Yeah? So could you confirm me that you are okay?
Yeah, that makes sense.
All right. Okay. Yeah. Very good. Let us look at more. Clean this. Okay. So I show you questions now, and probably most of the problems now you'll be able to do, and tomorrow we'll have our class again at 9. I will open at 9 tomorrow. Minimum, then you can say it's minimum in here. So then this one is a minimum in here. Now let's look at the next part of it. Say at the point Q. So this is the point Q here, you see. This point Q is very similar to that one. You can go up and also you can go down. So this is the point you can go up in here, and you can go down also in here, right, through the surface. So this point is neither max nor mean. What about this point here? Can you imagine what this point is? From this point, all the points are going down, isn't it? Nothing is going up. But from this, you can imagine from the surface. So all these are going down, so that's why you can call it max. So this is the minimum, no max, no mean, and this is max, right? We can say that. Yeah. So you can just study from those graphs and understand what we have. Same thing here, some graph they gave us, so we do not need that much, okay? Okay. And then other things we will discuss next day. So some part of this section you can easily do. All right.